We have a real treat for you this evening, and I'll leave it to our colleagues at the Lemelson Center to give you a little bit more background and detail on what we're going to do here this evening. But I just want to, first of all, thank Art Malella and his team for inviting us in once again to do the Open Minds exhibition here and to host this evening's program. This is really one of the high points of every year for us, and it's especially really a high point and special when we were able to do this at the Smithsonian. Tonight you're going to have the opportunity to see the student innovators, to learn a little bit more about what they're doing, to talk to them about the journey that they're on, but also to get to know each other a little better. But before we do that, we're going to bring a focus on one of the things that people often don't think about very much, but has an enormous impact on all of the work that you do, which is the physical environment in which you're doing it. You're sitting in a room with seats that are fixed, facing a certain direction, that set you up for a certain kind of behavior, for example. So we're doing some exploration this evening around space and its impact on learning and creativity and invention. We're doing that in a creative way, and I hope you'll enjoy this evening's program. It is my distinct pleasure to bring up Art Malella, who is the director of the Jerome and Dorothy Lemelson Center for the Study of Invention and Innovation here at the National Museum of American History. And I've had the pleasure of working with Art for many years now in collaborations around a variety of topics that relate to invention and innovation. And as a historian of science and with a deep and rich background in many different dimensions of the ways in which society and culture impact on creative outputs, I have to say that I never leave a conversation with Art without having some new thoughts and some real stimulation that I have to go away and sort of think about for a while. So I think you'll find this evening that you will leave here with some things to think about, some stimulating ideas. And please join me in welcoming Art Malella.
Thanks, Bill, for that great introduction. And hello, everybody. And I can't tell you what a pleasure it is to have you here. I can just feel the level of excitement that's out there in the hallways and in here today. And this is now, I don't know, about third or fourth time that we've hosted the Open Minds events, and it's just a thrilling time of year for us when this happens. I think it ranks up there with basketball for this time of year. So once again, we're proud to partner with you all, with the NCIIA, to present Open Minds, a showcase of the state-of-art innovations by student inventors, you. And you'll have the opportunity to see this tonight, but come by tomorrow morning at 10 o'clock and stay till 2, and after if you'd like, but there'll be a continuing showcase at that point. Just want to mention at the outset that the Open Minds is a natural extension of the mission of this Lemelson Center at the museum to encourage the exploration of invention and innovation, to encourage inventive creativity in young people who are young people. In addition to programs like this, the Lemelson Center shares stories of American ingenuity through scholarship and exhibitions. The topic of our upcoming exhibition, by the way, is called Places of Invention, and it's a fitting companion to tonight's exploration of spaces of invention. There's a kind of distinction that you will hear as we move on. For 15 years, scholars at the Lemelson Center have been studying the historic and modern communities where people, resources, and spaces have come together to spark inventiveness. Places of Invention, our exhibit, is scheduled to open in spring 2015, and we'll ask the question, what makes a place a hotbed of innovation while a similar place may actually fail? I think it's something we should all ask ourselves. Place, or rather space, is the theme tonight as well. So shortly, and I use the word shortly advisedly because these are going to be very fast presentations, you will experience a set of brief, lively presentations exploring physical spaces in which young innovators are educated every day, the physical spaces where invention and innovation happen. I should say at the outset that there will not be a Q&A for this. The whole idea is to get through this quickly and get through the goodies outside there. but you will appreciate this nevertheless. So, and you'll have ample time to talk to the presenters over a glass of wine or beer next door. And because the presenters are under intense pressure to do all this in 3 minutes and 40 seconds, please turn off your cell phone so nobody gets discombobulated by this. Okay, let's move right into the program. Our first presenter is from the University of Michigan. John Marshall's research focuses on design methods, tangible interaction, and cross-disciplinary collaboration. His approach to designing, making, and teaching recognizes the boundaries of the problem being addressed, not the artificial boundaries of traditionally defined disciplinary practice. Marshall is an assistant professor at the Stamp School of Art and Design and an assistant professor of architecture at the Taubman College of Architecture and Urban Planning at the University of Michigan. Mr. Marshall.
Hello. Okay, so I'm going to talk tonight about a course I've been running at Michigan with support from the provost. The course is titled Smart Surfaces, and the subheading or category for it is a hands-on think tank. And the hands-on part is very important because we actually do stuff. We get in and we get our hands dirty. Most of this happens through collaboration, negotiation, and experimentation. The fact that we make projects is almost like a secondary part of the course. And this is what our plan of where we do it. This is Design Lab 1. It's a 2,500 square foot space. It's actually housed in the library. So it's a reconfigurable space within the actual library building itself. As you can see here, it's can be used for many different types of things like brainstorming or presentations, but we've also poured concrete in it, and we've also put 10,000 volts into the walls to see if we could stick things to it. It's a meet together course, so we have 3 professors in there at this, every class period. We have 24 students that we organise into 4 teams. The faculty role is to cut red tape and to leverage the assets of their departments. Design Lab 1 is our base camp. We use it as a way to tactically appropriate parts of the university. So this is not my lab. This is a borrowed space which we use to basically extend out into the university. Part of the reason why we extend out into the rest of the university is so that we can actually appropriate resources. Having 3 faculty opens doors that we normally wouldn't, and it allows the students that have experience of resources to teach each other. Now, a key part of the course is to make sure that we question everyone's assumptions, including the faculty. And for that, we bring in a range of cross-disciplinarians as guests. Okay, so you're asking yourself, what's a smart surface? It's an intentionally underdefined entity. One of the things we want the students to do is ask themselves, what is a surface and how do we make it smart? So every week, the students are required to make a functioning prototype. We are very disapproving of hand waving. You know, we like to see actual things, and we actually like them to actually work. A key tentpole, if you like, of our things is the final project. We actually give the students 0 points for the final project. We grade them on how they make what they're making rather than what they make is. The Centre for Research and Learning on Teaching at the University of Michigan surveyed 14 multidisciplinary courses. Smart Surfaces actually came out with significant increases. We were between 5 and 53% higher than most of the other courses. Let me tell you why I think that's the case. The students, because of this format, they have to examine their own and other people's assumptions. And this isn't just theoretical, it's not just exposure, they actually have to wrestle and negotiate with each other under the constraints of deadlines and budget. Okay, they have to pool their skills and knowledge, they have to establish shared values and goals, they have to deal with egos and preconceptions, their own, their peers, and also their faculties. They have to debate the criteria for success. For example, engineers know their GPA to 3 decimal places. Our students don't necessarily know their GPA exists. Okay. So, point here is This is about spaces of invention. I haven't really been talking about a particular space. I've been talking about a network of spaces, not of invention, but for invention. And that's how I conceive of the university, as a network of spaces for invention. We don't have to pull down or blow up silos, we just have to drill some big holes in them. Thanks.
Thank you, John. I especially love the idea of not grading the final project at all, just grading how you get there. It's like a mathematical proof. Did you do it elegantly or not? It didn't matter if you actually proved anything. That's quite wonderful. So moving right along. Next up is David Narum, a former college professor now working in the area of creativity, innovation, entrepreneurship, learning and learning spaces, as co-owner of Greenway Partners, consultancy in Arcata, California. He's been part of the Washington, D.C.-based Learning Spaces Collaboratory since 2010, working to better understand the relationship of space to learning and creativity in undergraduate and K-12 settings. He is currently developing a creativity professional development training program for teachers in K-12 schools to use as a guide for teaching the national core curriculum. So, David.
Wait for it to kick in. The tension mounts. We all have our own space of invention, our brains. During millions of years of evolution as a species, it was our growing brains that were the source of our myriad inventions. When we invent, we connect things, neurons, objects, disciplines, maybe a stick and something to cook. We learn to connect things by doing and by observation. As we evolved as a species, doing, observing, and borrowing from other cultures, we learned to make better connections and better inventions. We learned to adapt. Dramatic climate swings over millions of years furthered our brain development and adaptive ability. We learned to live in a frozen tundra and how to survive a Washington, D.C. summer. Our adaptability comes from our ability to invent, to diversify our options. Our ultimate success as a species may rest simply on how good we are at keeping our options open. Even so, as Stephen Jay Gould notes, we live in a society driven, often unconsciously, to impose a uniform mediocrity upon a former richness of excellences. Today, uniform learning spaces and disciplines are literally and figuratively boxing learners in, restricting choice and muting our natural creativity. Standardization, questions with only right or wrong answers, the stigmatization of failure, these all reduce learners' creative and daring thinking and their ability to envision new options. So, recently I heard someone ask on NPR, who will create the next billion-dollar invention? But perhaps we need to ask, how do we create the next billion inventions? Or the next billion inventors? One way we can do this is to create unstandardized learning spaces, spaces ripe for connection making, uniform spaces that are also chaotic, spaces that combine structure and improvisation, spaces that foster autobiographical thinking through models, demonstrations, practice, and reflection, spaces where learners learn to see themselves differently. Spaces full of opportunities for learners to see themselves as police officers, inventors, spaces that enhance their identities and build agency. Agency, the self-belief that's critical for becoming an inventor. Spaces that help young inventors take the uniform roles that are often imposed on them and restory them as part of a larger, million years running human invention story. And today, the internet quite a human invention, can foster connections that allow for doing, observing, borrowing, restoring, and inventing on a global scale. So we know enough now to invent better learning spaces. We have the knowledge. Spaces where learners can envision and invent the options we need to adapt into the future. In such spaces, we will undoubtedly find our richness of excellences. Thank you.
David, thank you for plugging Spark Lab here at the Lemelson Center, which is going to reopen in 2015, so stay tuned on that. I have to say, it was a brilliant slide to start with. The brain is a place of invention, and it strikes me that's probably the only place of invention that exists. On the other hand, I was very depressed by seeing that sort of punch card thing with standardized tests as well, but that's okay. Our next presentation. Maria Oden is a professor in the practice of bioengineering and director of the Oshman Engineering Design Kitchen at Rice University in Houston, Texas. She's lucky to spend most of her time encouraging students from all descriptions to use their skills to solve real-world engineering challenges and to achieve successes they did not believe were possible. She's the 2012 winner of the ASEE Fred Merrifield Design Award, given to one engineering educator annually for excellence in teaching engineering design. Maria.
So I'm going to present to you tonight the Oshman Engineering Design Kitchen. A number of years ago at Rice University, we felt the need to unite students from across the School of Engineering to provide a space for students from all disciplines to design, create, and deploy technologies. So we created the Design Kitchen. This is a space where this year 795 students are developing technologies as we speak. These students get ID card access and are able to use the space 24/7. And in our machine shop, they do their own machining. They have access to the various machines. That is the one place where they aren't able to use the machines except for when there's a machining technician on site, but they do the work themselves. In addition to this, we have prototyping machines, laser cutter, 3D printer, printed circuit board mill. When I bought 4 sewing machines, everybody thought I was crazy, but they are used all the time. The students are, these fancy machines don't solve challenges for students, but what they do is provide them a venue that they can prototype really rapidly and then test their inventions. In the collaborative workspace, students, faculty, outside educators, outside mentors come together to create and to learn. Students have dedicated work tables where they come to work. This is their office, and they get vested in the Design Kitchen because they have their own space. And what we find is that we create a community of inventors right there in the Design Kitchen. There are 2 things that are very important to us in the Design Kitchen. One is that students work on real-world design challenges and that they work on interdisciplinary teams. And what we find is that when we put students who haven't worked together before, they're immensely creative and they're able to solve challenges that people care about, real-world challenges that come from industry, come from physicians, come from our community partners. And these interdisciplinary teams are remarkably successful in creating their designs. This is an example bubble CPAP system that was designed by an interdisciplinary team. 2.5 years after it was invented, this technology is now being scaled up thanks to NCIIA and USAID countrywide in Malawi, and it is saving babies' lives every single day. The giraffes at the Houston Zoo are no longer bored and eating too quickly. They're eating from a device that was designed by our freshman design students. We're really addressing a need that the zookeepers came to our students with. So there are no more bored giraffes in the city of Houston. Our computer science classes, where we used to have just code writing, now they're building robots and playing Quidditch matches at the end of the semester, where each robot has their own code in there and they fight, the colleges fight. It's amazing. Our students are able to get coaching in the Design Kitchen for making oral presentations and written presentations. And once they are coached, they go out and present to the community, like a presentation at NASA or in other venues. There's never a dull moment at the Design Kitchen. We have weekly innovation challenges. We have dinners where we bring together students, engineering professionals, and alumni around a particular technology or concept, and we have dinners and talk. The community comes in. 750 K-12 students have visited this year to get design challenges and work on them together. Their teachers take some of these ideas back to the classroom. So there's never a dull moment. And because of that, we, in 4 years, are busting at the seams. We are moving over the course of the summer, adding a new floor where there are more tables and more innovation spaces for the students to work in. I encourage all of you who happen to be visiting the city of Houston to come visit us, and I will explain to you then why it's called the kitchen.
Hey Maria, that was a delicious presentation tonight, and I just think it's a brilliant metaphor to talk about design kitchen, and we do want to hear about that. The only reference you made to food was this dinner and oral presentation. So, for our next presentation, it's actually prepared by two presenters. Helen Chen divides her time between researching entrepreneurship education with the National Center for Engineering Pathways to Innovation, also known as Epicenter, and introducing e-portfolios to students, faculty, and staff at Stanford University. Joining her is Robert Emery Smith, the Director of Technology Services for the Office of the Registrar Product Designer at Play in the fields of academia. And tonight, Robert Smith is going to do the presentation on behalf of both of them.
Good evening. Bring this over here. Let's step into this. This is a classroom back circa 1350. It actually may look a little similar to you or a little familiar to you because you've got a lecturer over on the left-hand side and you've got students behaving as students do, even one in the back row is falling asleep. Back in the late 90s, the Wallenbergs of Sweden and the faculty of Stanford University realized they had a common interest in looking at how to bring modern technology and modern tools to application in modern residential classrooms. And so the Wallenbergs gave us a gift to develop a place called the Wallenberg Global Learning Center. The spec for the place was really simple. Build us the best socket we can afford. That is to say, not a place that enshrines whatever tools happen to be current at that time, but rather a place that would adapt easily and readily to accept new tools and new techniques as they became available. This is the building. We took a 100-year-old building on the quad, cut the entire inside out of it, put in a new steel building to replace it, and left the original sandstone skin on the outside of the space. Since it opened in 2002, it's been a global resource for innovation and invention and learning. So what about it makes it useful as a site of invention? Well, the place itself is sort of a clean, well-lighted place for learning. It's white walls, wood trim, and we rely on the students, the faculty, and the content of the classes coming into the space to bring the color. The first decision that every faculty member has to make when they come into one of our classrooms is what's the arrangement of the classroom going to be? These are 4 arrangements of the millions of possibilities that you could have in there, but they can change the classroom for each different activity as required. The tools in the rooms are general purpose tools that can be used for just about any kind of purpose that people already know how to use. But that space and place doesn't matter. What matters is culture. We have to have culture in the space that recognizes the value of innovation, rewards failure, because that tells us a lot as well. And to carry that culture forward, we need really fun staff. Staff who are interested in learning, who are active, who have a strong sense of play. And so we have faculty, staff that are very carefully chosen to work with faculty in that way. Partnering staff with faculty so that they can try new and exciting things, we end up creating an environment where faculty, students, and researchers can create and invent entirely new curricula, entirely new paradigms, pedagogy, and modes of assessment. So what does this actually look like in actual operations? Every year at Election Day, there are 2 journalism classes that gather to report out the smaller elections that are going on in the area, municipal elections, bond issues, things like that. And they are working with Knight Fellow professional journalists as their editors, and they're working real-time publishing to Peninsula Press, which is a website that gets picked up by PBS, Bay Citizen, and a number of other mainstream journalistic outlets. Other faculty, since it's not a competition to see how spectacular you can be, other faculty just use new media to try to do new and different things. This DNA of this space is spread over a lot of places, from Cal State University system in California, as well as the community colleges nearby, and this room, which is at Uppsala Universitet in Uppsala, Sweden. MOOCs, flipped classrooms, these are all new techniques that are coming to the fore for us, and we, like everyone else, are trying to figure out, how do you use these things in residential educations? You can probably guess what our bias is. Our bias is that you have to remember what the nature of the beast is. We are social animals. We're fundamentally social animals, and so applications that will leverage the social impulse are applications that are going to work. So Wallenberg Hall is, in fact, a site of invention, because it has always been the home of a community of inventors. Thanks.
Well, thank you very much, Robert and Helen, for an excellent presentation, and especially intrigued by the playfulness of that presentation, which, as we know, is pretty critical to this kind of creativity that we're discussing tonight. I haven't been in the classroom for a long time, but I think that the clothes are actually the same in universities as they were. Is that right? Yes. Okay.
Yeah.
Next presentation is by Craig Forrest. He's an assistant professor in the Woodruff School of Mechanical Engineering at Georgia Tech, with research interests in biomems and neuroengineering tools, and teaching interests in invention competitions and design-build courses. Georgia Tech, he is co-founder and the organizer of one of the largest undergraduate invention competition in the U.S., the Invention Prize, and founder-organizer of one of the largest student-run prototyping facilities in the U.S., Invention Studio. So please welcome Craig Forrest.
Thanks for the kind introduction. It's really great to have a full audience of enthusiastic folks here tonight. It's really my pleasure to come up here and tell you about the Invention Studio at Georgia Tech. This is a facility we've created in the past 3 years. It's about 3,000 square feet. It's got about $500,000 of equipment in it. And it's your standard stuff: 3D printers, laser cutter, water jet cutters. We've got about a dozen 3D printers, 3 laser cutters, and so on. But that's not what makes it special. What's special is, so there's lots of machine shops in the country, and they're wonderful. But what's special about this place is that it's run 24 hours a day for free to use. It's run entirely by undergraduates. Okay, so there's a club called the Makers Club, which has been started at Georgia Tech, and they staff this place. They'll train you on the equipment, they'll repair broken equipment, they keep it open. Okay, there's no staff in there, there's no faculty in there. So as the faculty advisor, I just meet with them once a month to say, hey, what are the new toys we need to buy? It's wonderful, it's wonderful. They're doing all manner of things: Valentine's presents, Christmas, robots, what else have I seen in there? Lots of classes. This supports about 25 classes at Georgia Tech. There's no programming, so the classes can use it as they want, come and go when they want. Lots of research projects, of course. Georgia Tech's a huge research university. So we don't discourage any of that. It's open to all majors, all years. This is a student working on his BattleBot. These students are showing us the way. They're showing us interdisciplinary projects. They're showing us when they want to work, how they want to work, and what tools they need. I'll give you a few more numbers while we're at it. We run through about $100,000 in materials and supplies per semester. That money trickles down from the capstone program that I run. So we've got, this is a drawing robot that one of the students designed and built on his own. So you load a JPEG in your computer and press print and it draws it. So the capstone program, we've got hundreds of companies that want to recruit Georgia Tech students. The student built her own guitar, that's pretty cool. The companies give $10,000 apiece to work with the capstone team, and most of that money trickles down to the Invention Studio. About 10% of the students in the Invention Studio, that is 500 a month. 500 students per month use this place. 10% of them are from capstone, and everybody else is just building their Valentine's or research projects or whatever in there. And I thought originally, should I allow this company money to go to support robots for people's dorm rooms, but ultimately realized, hey, they're learning how to design and build things. They're here at midnight welding, and it's wonderful. So you're probably thinking safety, right? Safety is a big issue. We somehow balance safety and responsibility with freedom and creativity. And we've tried to inculcate those values. There's no full-time machinist. There's no rules on the wall. This is one of the laser cutters. One of the ways that we inculcate safety is we sort of personalize it. So Michelle Dufault was a student at Yale who died last year when her hair got caught in a lathe. It's tragic. It's just tragic. And we one week every semester, we put her picture up, and we sort of have Michelle's week, and it sort of personalizes it. Like, these machines are serious, and I'm here with my work buddy late at night, and I need to take this seriously. So we think that does more for awareness and a safety culture than having rules on the wall or having a grumpy old machinist who shuts the place down at 5 o'clock, which is the kind of machine shop that I had when I was in school. So it's transforming our culture at Georgia Tech. These prototypes are featured in the Invention Studio and all the capstone design courses and hundreds of other projects. I'm happy to take any questions you have afterwards. But it's all student-driven, and really I can't take credit. It's the students. Again, 70 undergrads run this place 24 hours a day. Oh, this is fun. They've created their own night classes. So here are the students teaching how to program the Arduino microcontroller. Totally created and run by the students. They also have classes on bookbinding and knitting. And it's just really fun to see this. It's the classes they want to be able to take at Georgia Tech, but they're not taught, so they created them. We transformed the lobby into a sort of assembly and test space. So there's 5 rooms totaling 3,000 square feet, and then there's sort of this lobby space where assembly and testing happens for a lot of the different projects. There's 10,000 College of Engineering undergraduates at Georgia Tech. So it's the largest engineering school in the country, and so a space like this is sorely needed. And lastly, these are some of our generous corporate sponsors for the capstone class who've given the $500,000 that allowed us to put this thing together over the past 3 years. Okay, thank you very much.
Craig, that was really very interesting, especially the kind of freedom you're willing to grant the students and in essence give up control to a certain extent. One of the things we found in our own exhibit that we're developing now on Places of Invention is that balance between freedom and management is really critical to the success of such a place. It was good to hear that validated here. Our final presentation is from Jared Carr. Jared is a third-year mechanical engineering major with a minor in energy engineering at the University of California, Berkeley. Jared co-founded the Design Engineering Collaborative at UC Berkeley. We keep hearing this word collaboration throughout these presentations, these identifications. This collaborative serves as a launch pad for ideas and creativity for students outside of the everyday classroom environment. He has worked to foster a paradigm shift in the way engineering is taught at Cal, when a group of his peers convinced the university to establish a charter for a new engineering design institute on the campus. He's a licensed private pilot, an exceptional bowler, we'll hear about that, and his research interests focus around green technology and renewable energy. Jared.
Thanks. I'd love to meet all of you, but I'm going to get a picture first. So let's get a big smile. Awesome. Thanks. So I'm Jared. I started the Design Engineering Collaborative, which serves as a hub for innovation on campus. And what we aim to do is tap into UC Berkeley's vast student resource pool through the implementation of an open source design center. And that's called the SHED, the Student Hub for Engineering Design. And this space has been inspired by visits to IDEO and to Stanford's D School. And we realized that we don't have anything like that at UC Berkeley. So we started a student organization. Within 3 days, we got handed a space that was an oversized junk closet. And we turned it into a collaborative zone full of whiteboards. And our final product, well, before we get there, we treated it as a design project. So we brainstormed, we conceptualized. These are our early mock-up prototypes of what we wanted to make and then how we actually implemented them. And what we ended up with at the end of the day was over 400 square feet of whiteboards, modular furniture. The room can be rearranged in many different ways. Basically, it's a blank canvas for ideas to run all over the walls. So what we did after we set up the space was we got students involved. So I brought together a group of student leaders from design, engineering, and entrepreneurship organizations to see what the culture of innovation was like on campus, to see what the students really wanted. So at the end of the day, there were too many cooks in the kitchen. We branded the color. We added color to deck, and we created a culture of innovation. We brought the Post-it notes, we set up brainstorming kits, and we had a really awesome event where Dennis Boyle, one of IDEO's co-founders, came, gave a talk, and then led a brainstormer for 100 students in our space. And it was the first time we were able to really see that people cared at UC Berkeley about this, and it was great. And since then, the momentum has been incredible. We have students getting their hands on with almost no resources except for what we were able to scrounge together because we care. And they're making things, learning design thinking, being taught by their peers, and then real things are happening. What's great is that the mechanical engineering students have stuff to do. These are groups working on foldable cardboard bikes, bike locking, bike sharing systems, a new rotor system for the John Deere lawnmower. But there's something for everyone. In fact, this was a cool project. Motorola came to us and said, hey, we are trying to come up with a boombox system for our phone. Can you guys come up with some cool ideas? So this uses what's called a sound laser, which shoots a directional sound beam at you, so I could say something and only you would hear it. We have software teams. Social calendar is like, what are all my friends doing right now? If they're not doing anything, I'm going to tell them. Radio tape is a collaborative music production software, so you can record a guitar riff, send it to your friend. Coming soon, Campus Card. Imagine Mario Kart with an RC car, Google Maps, and using your campus as the track. We're going to have a competition with Stanford with this project. Really excited about that. So let's take this one step further. What we found with starting the Design Engineering Collaborative is that this system of education isn't ideal. More can happen. And if we implement active learning spaces where classes can be taught in a way that allows people to come together and collaborate in ways that are not possible in a seating arrangement like this, great invention will happen. So I want to leave you with one note, something that I learned when I was a lot younger from Field of Dreams. If you build it, they will come. Let's create a space, let's create a culture, let's provide the resources, and invention will happen. Thank you, guys.
Aha, the smoking stove. Did you hear that? Kitchen came up again. It's getting a theme. Keep hold of that subtext in this thing. Thank you very much, Jared, and to all the presenters of the lightning rounds tonight. They were really wonderful. I don't know how you did it and kept your cool. I couldn't do it. What these presentations and the research that has gone into places of invention here at the Lemelson Center confirm is that when it comes to invention and innovation, place and community really matter. I want to thank you all for your attention tonight, your rapt attention. I know you're going to enjoy meeting the young NCIIA innovators and hearing about their inventions. I'd also like to thank the teams at the NCIIA, the Lemelson Center, and the museum for all their hard work. I'd like now to bring up Eric Phelps, who is going to tell you more about what's coming up next. Mr. Phelps, are you here?
Here. All right, great. So it is certainly a brave thing to get up and do the presentations that were amazing, awesome. One of the ones we heard about tonight was who's going to be the next billionaire, right? So tonight, as you head out, you're going to be deputized with some funny money. It actually says here, 1 million very fake bucks, okay? So you're going to head out back where you came in. There will be a reception, there'll be a program guide of all the teams that are presenting tonight. You're going to get some funny money. And you're going to vote with your money. You get 3 of these bills, so you get the opportunities to stick those in the boxes of the groups that you think are the most promising, that you're most enthusiastic about. We will count that funny money up. At the end of the evening, we'll actually award some real money, $1,500 to the winning team. So your vote counts. Doesn't always feel that way in the world, but it does tonight. So please, as we adjourn here, you're going to exit right out. There's also food and drink and plenty of everything. Please mill about. Thanks again to the Smithsonian for hosting, and we hope you have a great evening.